Hello everyone, welcome back to my YouTube channel Trouble Free. In today's video I'm going to explain you about power factor improvement and the methods for power factor improvement in the subject of basic electrical engineering. So in this video we will learn first what is power factor, what is the formula of power factor, why do we have to improve the power factor, how to improve, and what are the different methods. Okay, simple. So power factor is nothing but we usually represent it with cos theta, and that is ratio of real power to the apparent power. So what is real power, what is apparent power, you may get a doubt. Okay, cool, don't worry. First, real power is nothing but the usable electricity, that is the electricity which you are actually using is the real power. Reactive power means when you are using the electricity, some electricity will be wasted, and that is called the wasted electricity. That wasted electricity is called as the reactive power. Next, apparent power. Apparent power is nothing but the algebraic sum of both real and reactive power. Simple logic, guys. Real means the electricity which you are actually using, reactive is the amount of electricity which is being wasted, and apparent is the algebraic sum of both this real and reactive. And power factor is nothing but the ratio between the real power and the apparent power. Okay, so let us understand it with a right angle triangle. So as I already said, power factor is cos theta, right? So cos theta means what formula according to trigonometry? Adjacent side by hypotenuse. So what is adjacent side to theta here? Real, kW. And what is hypotenuse? This is the hypotenuse, right? Apparent, which is nothing but the algebraic sum of real and reactive. Algebraic sum is nothing but root of kW square plus kVr square. Hypotenuse means what? Hypotenuse square is equal to side square plus side square according to Pythagoras theorem. So hypotenuse square is equal to side square plus side square, then hypotenuse will be equal to what? Side square plus side square under root, right? So this is how you get this. Now this is the formula for power factor. Then how to improve the power factor and why we have to improve the power factor, I'll tell you now. See, how to improve the power factor. Before that, what do you mean by an efficient power factor? If the value is equal to 1, then it is said to be efficient, that is the power factor is good. So how to make it as 1? By making this kVAR as 0, that is you will be making the reactive component as 0. This is the real component and this is the reactive power component, right? You need to make this one as 0. So when you are making it as 0, what will happen? kW by root of kW square plus 0. So you will get kW by root of kW square. So here square root cancel, you will get kW by kW. When you cancel, you will get 1. So you got the power factor as 1, right? That is, it is efficient condition. Power factor is 1 means what? The reactive power is 0. If the reactive power is 0, you are paying the current bill for only real power, that is only for the power which you are actually using, only for that power you are paying the current bill, right? Which means you are not paying any money for the wasted electricity. Got it? So this is about the power factor improvement. Why we have to improve the power factor? In order to reduce the amount of bill we pay, we need to improve the power factor. Now let us see what are the different methods we have to improve this power factor. So we actually have 3 methods, if you can see here. Yeah, static capacitor and synchronous condenser and phase advancer. Okay, we are having 3 methods. So let us discuss about each of them now, and don't worry guys, it's not going to be complicated. Initially when I watched few videos or when I have seen the theory of this, I felt it is a bit complicated and I thought of leaving this topic seriously, but still I thought of giving a last try. Let me try to understand. I took some time and I really understood this. Okay, so it is going to be easy for you, don't worry. So first is by using the static capacitor. So static capacitor, you nothing but, see, you will have the load, right? You will be placing a capacitor in parallel to that load, which means, I'll tell you, very simple. Before that, you need to understand one simple concept, which is inductor. In inductor, current will lag. In capacitor, current will lead. See, in the first video where I explained about the basic circuit components, I've explained that in inductor voltage will lead, right? Voltage will lead in inductor, and in capacitor voltage will lag. In the first video I've explained about this. See, here voltage is leading means current is lagging. In the capacitor also, the voltage is lagging means the current is leading. Okay, so now what is our main goal? We have to reduce the reactive power, right? So actually this reactive power, you understood what is reactive power. It is wasted electricity. So this reactive power is a inductive component. It is not a capacitor component. It is a inductive component. In inductive component, what is happening? Current is lagging. So obviously in reactive power, current is lagging. Okay, reactive power is an inductive component. Since in inductor current is lagging, here also the current will be lagging. So we are having some lagging current in the inductor. So now what we have to do is, we have to eliminate this lagging current. How do you eliminate the lagging current? By adding the leading current. Okay, so how you can eliminate the lagging current? By adding the leading current. So leading current will be given by whom? Capacitor. So that is why you are placing a capacitor in parallel to the load. Got it? So lead plus lag, total it will become neutral. That is, the reactive power will become 0. See, I have written here, the reactive power will become 0 if you are eliminating the lagging current. How to eliminate this lagging current? By using the capacitor. Why? Because capacitor is producing the leading current. So lag plus lead will become neutral, so the power factor will improve. Now see the diagram, I'll show you. So this is normal before you placing a capacitor. So we have the voltage supply here, we have had the load here. Once you place the capacitor here in parallel to the load, see, in parallel to the load you need to place, not in series connection, you need to place it in parallel. So when you place it, it will provide leading current and here lagging current. Both of them together will become neutral. Okay, so this is about the first thing, static capacitor. Now let us see what are the advantages and disadvantages of this static capacitor. First is low losses. You will not have low losses, that is very negligible losses, minimum losses. Maintenance is less. It is light in weight and easy to install. Coming to the disadvantages, the age of capacitor is less, that is, you need to keep on replacing it. And once if the capacitor is damaged, it is very expensive to fix it. Got it? So this is about the static capacitor. Simple. You will be placing a capacitor in parallel to the load. Okay, so in all the three, in static capacitor, in synchronous condenser and in phase advancer, in all the three, the logic is same. You have to eliminate the reactive power. So in order to eliminate the reactive power, you need to add some leading current. So how that leading current is added depends. So in static capacitor, we have placed a capacitor. In synchronous condenser, let us see what happens. First of all, what is synchronous condenser? Synchronous condenser is nothing but it is a DC excited motor whose shaft is not connected to anything. So usually shaft is connected to the load, but here in case of a synchronous condenser, it is a DC motor where the shaft is not connected to any load. It runs freely, that is, it runs in no load condition. Got it? This is about synchronous condenser. This is what synchronous condenser means. Now let us see. Yeah, now this synchronous condenser is also called as synchronous capacitor as well. Okay, so capacitor means obviously it will provide leading current, and that leading current will neutralize the reactive power. Because reactive power is an inductive component, in this the current will be lagging. So in order to neutralize this lagging current, we are using some capacitor which will provide the leading current. Got it? Done. That's all. Very simple. So you are using a synchronous condenser. Synchronous condenser is also called as a synchronous capacitor. That capacitor will provide leading current which is required to nullify this lagging current. Okay, next advantages, it has a long life of 25 years and it has low maintenance. Next, coming to the disadvantages, it produces noise and it is expensive. Okay, so the third one is a phase advancer. So basically phase advancer also very simple concept. It is mainly used in the case of induction motor. So it is mainly used to improve the power factor of the induction motor. So what we will do is we will be connecting a phase advancer in parallel to the motor. Okay, then this phase advancer will provide some leading current. By that leading current, the reactive power will become 0. Okay, as I already said, in each and every method, in all the 3 methods, our main goal is to make reactive power 0. Since reactive power is a lagging component, we need to add some leading component. Got it? So see, this is the diagram. So this is the motor and supply, both are connected to each other initially. Then you need to bring a phase advancer and connect, which will provide the leading current, and the reactive component will be neutralized. Okay, got it? Next, advantages and disadvantages. Coming to advantages, it is very easy to use, and disadvantages, it is not suitable for motors below 200 horsepower. Okay, so that's all about this video, guys. I hope it is clear for you. And yeah, if you are having any suggestions, let me know in the comment section. And if you think that I'm speaking too fast, let me know that also. I'll try to, get down my speed. Okay, that's all. Let's meet up in the next coming video.